Here are some examples of graphs of polynomial, which is one continuous line from corner to corner. Here are examples of graphs of rational formula. The big difference is they have these vertical lines which separate the graphs. For example, here is the formula 2x of x minus 3. The roots is where x equal to 0 and where x equal to 3. It's undefined. That's where you have this vertical line. And this is the sign chart. The graph is not going to cross this line because it's undefined and equal to 3. So when the graph gets close to this line, it must go up or dive down. In this case, it goes up because if you plug in a number like x equal to 3.001, you can find out y is very large. So you get a point that's way up there. So therefore, the curve looks like this along the asymptotes. On the other side, it goes downward because the sign are negative. So we have this middle portion of the graph. And this is the behavior of the graph along a vertical asymptote. And these are the cases. And when the R order asymptote, you have plus and minus, you got two opposite directions. When even order asymptote, we got the same directions. And here's examples as x once gets very large. When x become very large, basically this fraction is equal to the two leading terms fractions, which in this case is equal to 2. So the points you plot is going to get closer and closer to 2. So you have this y equal to 2, I say horizontal line that with the curves level out against it. And this is a horizontal asymptote. Here is the graph of these functions, and we have root at 0 and the 2 asymptote at 2 and minus 1. So in particular, at the root, you the graph looks roughly like a polynomial, like a square. But along the asymptote, it must go downward because the signs are negative. Therefore, the middle piece looks like this. And to the right-hand side, when y becomes very large, basically, then the fraction is equal to the quotient of the two front terms, which in this case equal to 3. In other words, the point we plot will keep going up. The y levels out against equal to 3. Then along the vertical asymptote, it goes up. So the curve looks like that. On the left-hand side, similarly, the curve look like this. Here is the functions with asymptote at x equal to 2. We got two roots. And across the roots, we have the graph basically look like that. Along the asymptote, and the minus goes up, the plus goes up. Goes down, one goes up, one goes down. And along x become very big. Basically, they are equal to the head divided by the heads, which is equal to y equal to x. So the cogs are y equal to x. And that's it. Okay, bye-bye.